Can you all see my screen?
Yes, sir.
All right, good. Welcome to a new lesson. We're done with waves, so we are moving now to electrostatics. Does anyone know what the term electrostatics means? Come on.
Protocols that are made of electric fields.
Mahlati.
I guess.
I'm not very sure of the answer.
Okay. The term electrostatics consists of two parts, electro and statics. Electro comes from electricity, and statics come from something that is resting, something that is not moving, something that is stationary. So this is electricity at rest. So the definition that I have on the screen is that this is the study of charges that are at rest. That's electrostatics. Okay, now in electrostatics, we have two kinds of charges. The first charge is the positive charge. A positive charge on an object is when there is less electrons, when there's a deficit of electrons, that object is positively charged. Meaning, if there's less electrical charges on an object, that object is positive. And the second charge is the negative charge. This is where there's excess of electrons. When there's a lot of electrons, the object is negatively charged. So what is it that you can get out of this? They've talked about electrons in the definition of both positive and negative. It means electrons are the ones that move. Electrons move. So throughout our lesson, we're going to be talking about the movement of electrons. Electrostatics talks about movement of electrons. Okay, now each and every object consists of atoms. Kumani, what are atoms? What is an atom?
I forgot, sir.
An atom is the smallest unit. It is the smallest unit of matter. What is matter? Kuman.
I forgot that too, sir.
Mahlati.
Matter is anything that has a mass and takes up space.
That's true. So the smallest element of matter is an atom. Have you guys been exposed to a periodic table?
Yes, sir.
A periodic table has atoms on it. So this is what we're going to be talking about. Okay, on an atom has a nucleus, just like a cell, a human cell has a nucleus. And within that nucleus, there's neutrons and protons. And then around the nucleus, there are electrons. Now, electrons are constantly moving. Protons don't move, and neutrons also. So whatever that is in the nucleus don't move, but electrons do. Okay. Now, if you are charging an object by contact, let's say for instance, if you have a negatively charged woolen cloth and you want to charge a ruler, you cannot transfer the charges if you don't put them in contact. So during the process, when you're trying to charge the ruler, which I think most of you have done it before. Have you ever tried charging your ruler with a woolen cloth?
Yes.
Yes, sir.
Yes. So what happens there is that during the process, electrons are transferred from the woolen material to the ruler, not protons, electrons. They are the ones that move. Okay, now, for instance, when the glass rod is wrapped with the woolen cloth, electrons are transferred from the rod to the cloth. The rod has an electron deficit and is positive, and the cloth has an excess of electrons and is negative. So that's what happens. And the other rule of thumb is that like charges repel and unlike charges attract. Are you guys aware of that principle?
No, sir.
You're not aware?
No, sir.
Okay. If you put two positive charges together, they will repel each other. But if you put two negative charges, again, they will repel each other. But if you put a positive and a negative, they will all attract each other. Sort of like with human beings. Men are attracted to women. Men are attracted to women. 90% of the times, if you're a man and you bring another man, you won't be attracted to that particular individual. So it's the same thing with charges. Two like charges will repel each other. Okay. As you can see on the screen, glass rod is neutral and the woolen cloth is neutral, but within the neutral ruler and the neutral cloth, there are positive and negative charges. It is just that a neutral object has the same number of positives and negatives. That is why we call it a neutral object. A neutral object has the same number of electrons and protons. So if you put two neutral objects together, Mahlatsi, what will happen?
Sir, can you repeat again?
If you put two neutral objects together in contact, what will happen?
Not sure.
Nothing will happen. There won't be attraction and there won't be any repulsion. Why? Because there is equal number of charges. There is equal number of electrons and there's equal number of protons. What are protons? Kuman.
I forgot.
Protons, let me go back to the previous slide. No, let me not go back. But protons are positive charges and electrons are negative charges. So like I said before, electrons are the one that moves in the system. Negative charges are the ones that move, as you can see on the screen. Can you see on the screen the negative charges that are around the nucleus?
Yes, sir.
They are the ones that move. So electrons are negative charges. Protons are positive charges. Neutrons are neutral, meaning they are neither positive or negative. Okay. There's another phenomenon that occurs when an object is neutral. Like I said before, if you put two neutral objects, those two objects will neither attract or repel. The reason is that there are equal number of electrons and protons. But there are times whereby a neutral object can be uh, attracted to another neutral object. This phenomenon is called polarization. Polarization of charge. A polarization of charge is a partial or complete polar separation of positive and negative electric charges in a system. If you go to the term polarization, the term polarization comes from the term poles. The term poles. So, for instance, a magnet has south and north pole. So, if you have a magnet and you bring another magnet, the southern part of the magnet will attract the northern part of the magnet. But this only happens when there is separation of charges. If the charges are positioned in such a way that they are equally distributed, then your objects won't be attracted to each other. So this is what happens to a neutral object. Let's say, for instance, you have an object which is positively charged. If you bring an object which is positively charged to a neutral object, you see this big gigantic object. This object is neutral because there's equal number of positives and negatives. But if you bring a positively charged object close to it, all the positive charge ends of the object will be repelled and they will move towards the right. By doing so, they will be exposing the negative charges. Are you guys able to see my cursor?
Yeah. Yes, sir.
Yes. So do you see where I'm pointing the negative charges?
Yes.
Yes.
Yes, sir.
So if you bring a positive charge a positively charged object onto a neutral object, it will repel the charges that are on the surface, and they will all move towards the opposite end, exposing, if it's a positively charged object, it will expose the negative charges on the neutral object. So if you bring a negatively charged object, it will repel all the negative charges in the neutral object, and you will be left with positive charges on the surface. So when this happens, negative charges and positive charges will be separated. This side is positively charged and this one is negatively charged. So when this happens, the positively charged object will end up becoming attracted to a neutral object. And also, if you polarize two neutral objects like this, and then you bring the positively charged end of another neutral object, they will both attract because of the phenomenon called polarization of a charge. The reason why this happens is because if you bring a positively charged, the negative charges will be the one moving towards the surface, not the positive charge. The positive charges don't move, like I said. It is just that when the negative charge moves towards the surface, it leaves this side having less electrons, making it positive. Okay. Now we have another term of conservation of charge. Conservation of charge states that a charge can never be created or destroyed. It can only be transferred from one object to another. So whatever charge that has been created by God back in the days, it is still there and it can never be transferred, and also it can never be destroyed, but it can be transferred from one object to another. So that's the law of conservation of charge. A charge can never be created or destroyed, but can be transferred from one object to another. Another term, charge quantization. So each and every charge, the smallest charge that you have, has a specific quantity. The smallest charge is quantized. So all the charges are of multiple smallest charge, and the charge on one electron is 1.6 times 10 to the power of minus 9. So if you get a number which is more than that, it means you don't have, it means you have more than one electron. So Matat, let's say we have a charge of 3.2. How many electrons do we have in that system?
Not sure, sir.
Okay, if one electron have a charge of 1.6 times 10 to the power of 10 to the power of minus 19. If you have a system which has a charge of 3.2 times 10 to the power of 19. It means you have two charges. It means you have two electrons. Do you agree?
Yes, sir.
Mahlat, do you agree?
Yes, sir.
How did you get to that answer? You divide the charge of the system divided by the charge of one electron. That's when you will see the number of electrons. If you divide 3.2 divided by 1.6, it's actually 2. I think we are on the same page. Okay, now the last thing, I want to finish up all the definitions. Another definition, electrons are negative particles occupying a space around the nucleus. Matlati, what is a proton?
A proton. A proton is a positive charged subatomic particle that resides in the nucleus
That's
of
correct.
an atom.
That's correct. So electrons are negative and protons are positive. Electrons negative, protons positive, neutrons neutral. But unfortunately, I don't think we'll talk a lot about neutrons. You will talk about neutrons, I think, in grade 12 and university first year. Neutrons are neutral particles in an atomic nuclei. Protons are positively charged atom in an atomic nuclei. Now, there's another term, triboelectric charging. A triboelectric charging is a type of a contact electrification in which a certain material becomes electrically charged after they come into contact with another different object and are separated. In your syllabus, you'll be doing a lot of triboelectric charging problems. So what happens is that if you have two objects, say the other one is negatively charged and the other one is positively charged, if you bring them into contact, they will attract each other. But after that attraction, negative charges will move because they are always on the move, trying to neutralize. They will move from the negatively charged object to the positively charged object until the charge on both objects are the same. Please note, if you bring a negative charged object and a positively charged object together, negative charges or electrons will move from the negatively charged object or the object which has excess number of electrons. They will move or flow into the positively charged object until the charge on the negatively charged object and the positively charged object are the same. And then when you release them after separation, those two objects will either uh, repel each other or not get attracted to each other. But the worst case scenario is most of the time they will repel each other. Okay, so I'm just gonna do a problem on electrostatics. Then we'll be able to be on the same page. All right. Let me see. Document to, okay. Are you able to see what is on the screen?
Yes, sir.
All right. We're gonna do a problem on electrostatic. So I'm also trying to record. Um, I'm also trying to record the lesson. So I just need to do something quickly. Okay. Yeah, now we can go ahead. I just want to demonstrate what happens if you bring a negatively charged object and a positively charged object together. What will happen is that they will be attracted to each other. Why? Because like charges attract and unlike charges repel. Do we all agree?
Yes,
Yes.
sir.
All right. So when these two objects get into contact, negative charges will flow from the negatively charged object to the positively charged one. Let's say if the negatively charged object had a charge of 3 coulombs, then the positively charged object had, say, positive, uh, say, 4 coulombs. So these two objects will get attracted, and then when they meet, to money, how many electrons will flow from the negatively charged object to the positively charged object?
Yeah, I'm not sure, sir.
Okay.
One.
Matlati,
My answer is one or nothing.
oh, just one. Okay. If one charge moves to the 4 column, we will have minus 2 columns. Okay, 4 minus 1 will have 3 plus 3 columns. Unfortunately, that's not correct because I said after contact, the two objects must have the same charge. Okay, let's try to transfer um, four electrons. How many electrons will be left on the negatively charged object? Kuman. If we transfer 4 electrons, 4 negatively charged electrons,
Let it be one, sir.
we're going to be left with positive 1 coulomb. Mahlatsi, do you agree?
Yes.
Okay. So when those 4 electrons move to the positively charged object, what is it that we're going to have or on the positively charged object? Do you agree that it's going to be 0 coulomb? Because it's going to be plus 4 minus 4 from the electrons that moved in. Do you agree, Kuman?
Yes, sir.
Okay, unfortunately, again, the charges are not the same. Okay, let's say if we transfer 5 electrons. So what will be the new charge on the 3 on the minus 3 coulomb object? What will be the new charge if we transfer 5 electrons?
It will still be 2 electrons
Plus
charges.
not 2 electrons. To be left with a positive charge. Positive 2, you agree?
Positive 2. Yeah.
Mahlatsi, do you agree?
Yes.
Okay, and then the other one, minus 5 plus 4, it will be
Negative 1.
negative 1 coulomb. Are they the same? No.
No, sir.
So how many charges can we transfer?
Three positive charges.
Now, but positive charges don't they don't flow. They don't. You can't transfer positive charges.
How about we transfer 2 negative charges?
Okay, 2 negative charges. You'll be left with negative. You'll be left with negative 1 coulomb. Then the other one will be plus 2. Plus 2 because it's a 4 minus 2. Okay, so let us add the two charges and divide by 2. Minus 3 plus 4 divided by 2. How much are we going to get?
Will give us 0.5. in fraction to give us 1/2.
1/2 or 0.5. 0.5 each. Okay. In order for you to know the number of electrons you have to transfer, and first of all, is it positive or negative? Positive.
It's positive.
Yeah, that's true. If you want to know the number of electrons that you have to transfer, it will be because each one of them must be left with 0.5. It will be minus 3 plus the number of electrons, let's say x, equals positive 0.5. X will be if you take minus 3 to the other side, it will be how much?
Positive 3.
Positive 3. So you need to transfer, this will be .5. Yes, so you need to transfer 3.5 coulombs of charge. So if you transfer if you transfer 3.5 number of charges, you will be left here with 0.5. You agree?
Yes, sir.
Yeah.
And if you transfer that negative 3.5, you will have positive 4 plus negative 4 minus 3 minus 3.5, which is positive 0.5. You agree?
Yes, sir.
So from now onwards, you're gonna be using these formulas to see how many electrons you're gonna be transferring in your problems. Now let's get right into it. They say a small metal sphere carrying a charge of 2 times 10 to the power of minus 9 is placed on an insulated stand. There it is. How many number of electrons compare with the number of protons in A? They said choose from, is it less than or greater than or equal to?
Less than.
Meaning they said how many number of electrons? Do we have more electrons than protons on A? You said less than, and that is correct. It's correct because if you have a deficit of electrons, it means your object will be positively charged because there is less negative charges, which are electrons. So the answer is less than. Okay, now calculate the new charge on sphere A. I feel like this question was incomplete. Oh no, they said 10 to the power of 13 electrons are now added to sphere A. Calculate the new charge on sphere A. Come on, how do we go about this one? We have to go to the concept of quantization, which says that one electron is equals to 1.6 times 10 to the power of minus 19. Do you all remember this one?
Yes, sir.
That's one electron. But now we have been introduced to how many electrons? 10 to the power of 13.
13.
You agree?
Yeah.
We want to solve for the charge that is quantified by 10 to the power of 13 10 to the power of 13 electrons. What should we do in this case? Cross multiplication. You agree?
Yes, sir.
So x will be equals to 10 to the power of 13 times 1.6 times 10 to the power of minus 19. This will give us, hey, does anyone have a calculator? We'll have 10 to the power of 13 times 1.6 times 10 to the power of minus 19. So it says
it gives us in fraction, it gives us 1/6 to 5,000. In decimal, it gives us 0,016 or 0,60.
okay, so this will be 1.6 times 10 to the power of how much?
The power of 60, maybe.
Minus 6 coulombs. You agree?
Yes, sir.
Yes, sir.
So that is the charge of the 10 to the power of 13. If you introduce 10 to the power of 13 number of electrons, they will bring you a charge of 1.6 times 10 to the power of minus 6, because you are quantifying it. Now the question says calculate the new charge on sphere A. Sphere A is positive plus 2 times 10 to the power of minus 8. Then you have introduced another object which has 1.6, which is negative because it's electrons. Do we agree that electrons will
Yes.
bring a negative charge?
Yes, sir.
Yes, sir.
Times 10 to the power of minus 6. Now they said calculate the new charge of sphere A. So if you have introduced this number of electrons, you will have plus 2 times 10 to the power of minus 8 minus 1.6 times 10 to the power of minus 6. Remember, these are just electrons introduced, not an object. So
Okay.
these electrons will decrease the positive charge. So what is it that we get if you use your calculator?
It gives, tell me, negative 1,58 times 10 to the power negative 6.
Negative
Negative 6.
Negative 6 times.
No, it says negative 1.
Okay, let me rub this quickly. It says negative 1 times
Comma,
comma
58
58
times 10
times 10 to the power of
negative 6.
minus 6. Yeah, this makes sense. So this is the new charge. It means we introduced a lot of electrons into this object. That's why it ended up becoming negative. Okay, let's see what the other question says. Two spheric metal sphere B and C placed on an isolated stand carry charges of plus 4 times 10 to the power of minus 6 and minus 6 times 10 to the power of minus 6, okay, respectively, as shown in the diagram below. The spheres are allowed to touch. After touching, we know what will happen. Electrons will start to flow. Electrons will start to flow, and eventually the two objects will have the same charge. They said after touching, the spheres are then separated and brought back to the original positions, as shown in the diagram below. State the principle of conservation of charge. What? The principle of conservation of charge. Kumar.
When a negative reacts with a positive, gonna repel. Then when positive reacts with a negative, it's gonna repel. Then when a positive and a positive reacts with each other, they're gonna combine.
What you
It's the
said
same
is
story to
true.
me.
That's what happened in electrostatics. However, the conservation of charge states that in an isolated system, uh, charges can never be created or destroyed, but can be transferred from one person to another.
Yes, sir.
Conservation of charge. Charges can never be created or destroyed, but can be transferred from one person to another. It's like love. Love can never be created or destroyed, but can be transferred from one person to another. Love has been there ever since. The same thing with the law of conservation of energy. Energy can never be created or destroyed, but can be transferred from one object to another. The same thing with charges. They can be transferred from one object to another when two objects are in contact. Now they said calculate the number of electrons transferred between two spheres during the contact. So how do we go about it, Kuman? Calculate the number of electrons that were transferred. First of all, how many coulombs were transferred during the process. Whatever that I've put inside this box is what you are supposed to be using. The first thing first will be to add the two charges and divide them by how much? Kuman. Whatever I did in this box is the same thing that you're going to be doing. You always have to divide by 2. You add the two charges and divide by 2. That's when you will find the number of that's when you will find the number of electrons that each object will have at the end. And then you put those number of electrons or the coulombs that you got, and you equate, you take one object and take its charge, and then you add it to x and equate it to whatever you have found. Then you solve for x, then you will find the number of coulombs. So I think we're gonna have to do this one on the next lesson, which is on Tuesday next week.
Okay.
Yes, sir.
But are we all in the same page?
Yes,
Yes,
sir.
sir.
Mahlatsi? Okay. So next week we're gonna be continuing with electrostatics. I will post this video on YouTube, then I will share it with you guys so that you can just go back and refer.
Yes, sir.
Okay, so I'll see you guys next week. Cheers.
Okay, sir.
All right.
Well,